Hello, welcome to this semaphore exercise. This is not an introduction to semaphores. This is an exercise using semaphores. So this is a very simple exercise, but it does show how semaphores can be used. So what we're going to do is we're going to rewrite each of these processes code using semaphores. And why do we need to do that? Well, let's just take a look at what's going on here. First of all, we have three processes here, and they all want to input information. So but they're sharing the same input device. So what we want to do is we want to have mutual exclusion on the input device and allow only one process to access the input device at a given time. So that's the first thing that we want to do. The other thing we want to do is we want to have the work synchronized, meaning that after P1 has input A1 and A2, P1 will be able to use A1 to calculate Y, but P1 is actually going to have to wait to know that P3 has input the correct value for C1 so that the calculation will be correct. It's also going to have to wait to make sure that P2 has made the calculation for X before printing it. And the same is true here for P2. P2 can use B2, that is input itself, but it's going to have to wait for P3 to let P2 know that C2 has been input. And it's going to have to wait for the calculation of Z and also for the calculation of Y in order to calculate X. And over here you can see that P3 is going to need to wait for P1 to input A2 and for P2 to input B1. So it's a very simple exercise, but we will be using semaphores to synchronize this. Okay, so let's just remind ourselves a little bit about semaphores. Semaphores have three operations. They have initialization, and a semaphore is just a global variable, that integer variable. So the first operation is initialization. It's important what the semaphore is initialized to. And the next operation is a wait operation, which if the semaphore value happens to be a 0, then the process will wait. Or the process decrements. And with the signal, the process will increment. It will not test, it will just increment. And you can go back to the other notes and review how semaphores work, but this is just the gist of what's going on with them. So let's clear the slide, and now let's work on how we're going to synchronize this. Well, first let's take a look at the different semaphores we need. So I already said, we already discussed that we know that we need the semaphore for the input device, so I'm going to call that S. So I'm going to call it semaphore S. And this one will be initialized to 1 because when we get started, the input device is ready and available, and whichever process runs the wait first will decrement that value to a 0, and we'll then be able to access the input device, and then we'll signal when completed. So let's rewrite each of the processes code with the input, with the wait and signal for the input device. So we have, for P1, we have a wait on S, and then an input of A1 and A2, and then a signal. And for P2, we would have a wait on S, and then an input B1 and B2, and then a signal. And P3, we'd have a wait on S, and then input C1 and C2, and a signal. That's a parenthesis. Okay, these waits and signals are only for accessing the input device. These waits and signals do not have anything to do with letting the other processes know that the correct values have been input. We need to use additional semaphores for that. So what semaphores do we need? Well, P1 needs a semaphore for C1, so I'm going to call that SC1. And it also needs a semaphore for X, so I'm going to call that SX. I'm just counting. These are not the this is just a counting of the ones, how many we need. And P2 is going to need one for C2, so I'm going to call that SC2. And it's going to also need one for Y, SY. And it's going to need one for Z, SZ. And I think that's it. And then P3 is going to need one for A2 and B1. Okay, so now let's pick a different color here. I'll pick yellow, and let's initialize these. Well, what are we going to initialize them to? There's two things that we need to consider here. First, we need to consider what we're going to initialize these semaphores to. And the second thing is we need to make sure that our weights and signals do not end up causing a deadlock situation. So first, let's talk about what we want to initialize them to. Well, we initialize this mutex right here, this binary semaphore, to a 1 because the input device was ready and available. But in this case, we're going to initialize all of these semaphores right here to 0 because if you go back and you look, you want the processes to wait. You want to wait for the signal to happen so the signal will let the process know that the input has happened. So we're going to initialize all these SC1 to 0, SX to 0, SC2 to 0, SY to 0, SZ to 0, SA2 to 0, and SB1 to 0. So all of these semaphores right here, this is just the list up here, are now initialized to 0, which is forcing the process who's waiting for it to have the signal come first. Now, let's just take a look here at P1. P1 needs to wait to get C1. So P1 is going to have a wait here for SC1. Now, the other thing though is that P3 is also going to wait for P1, so it's going to have a wait here for SA2. Now the reason I put these down is because if I were to have this one wait here, and instructions go from top to bottom, so if the process P1 gets here and we're to hit this wait, and it's waiting for this one, it's just going to sit there waiting, it's not going to proceed past that until the signal happens. So that signal needs to be before this wait, because otherwise we would end up with these two sitting here waiting for each other and never progressing, and therefore they will not they will be in a deadlock situation. So that's important to take note of. So what we need to do is we need to have P1 here signal, which will change the value to a 1, which will allow this one to get past that. So it's going to signal SA2, and we want Z to also signal SC1 before waiting on anything else. So we want to make sure we have all of our signals first. So those two signals are there. Now also P2 has a wait for SC2. So we have another signal here for SC2. And P3 has a wait for SB1. So we will have P2 signal SB1. So let's do over here, we can do P3 first. P3 will signal that C1 has been input, signal that C2 has been input, wait for A2, wait for B2, and then proceed to make the calculation. Z equals A2 plus B1, and then signal that that calculation has been made. Over here we have P2. P2 is going to signal B1, wait for C2, then calculate W, and W does not need to be signaled, but will need to wait for Z, and we'll need to wait, I'm going to run out of room here, for Y. Then we'll calculate X. And then we'll signal that X has been calculated. And over here we have P1, which waited for, signaled that A2 was input, waited for C1, can now calculate Y, then must wait for X, and then can print X. So now we've succeeded in using semaphores to synchronize this work. Again, this is just a simple exercise that demonstrates how semaphores can be used. And I'm not going to draw all the arrows, but I will draw a few arrows just to show you what's going on here. So here we have this signal going here to that wait. And then we have this signal going here to that wait. And since the signals don't test anything, they will not get stuck in a deadlock. But if the weights were on top of the signals, they could get stuck in a deadlock. And then we have this signal going over here to this weight, and etc. This signal is going over here to this weight. And I'm not going to draw the big arrows that go across, but you can get the idea. So I hope this will help you to understand a little bit more about weights and signals and how they work, and how it's important to put them in the correct order and to do your homework.